Yes, we are again back here for electrochemistry, and this is Joseph Jobs Kaira Chemistry Channel. We are looking at electrochemistry for all level. Strictly, this is content for the ordinary level students, senior 3 and senior 4. Please subscribe to our channel after watching these videos for more of the same. Now, in our previous lesson, some of you, dear students, inboxed me and told me you couldn't access the lab to carry out that experiment to the COVID-19 restrictions. I'm back here to briefly borrow some knowledge and show you how you could see this experiment virtually so that you may not forget really what happens during discharge of ions, what you observe, or strictly to know what happens during electrolysis. This is our lesson 6. I'm not going to do a lot during this lesson, but I want to show you a video to show how the experiments would be done. The experiments discussed in our previous lesson 5. How can they be done? And then I'll add on something to summarize that so that we link up to our next edition of these lessons, which will be preferential discharge of ions. Kindly watch this video and really see what happens during electrolysis.
Draw a pencil line across the middle of a strip of filter paper. Place it on a microscope slide. Moisten the filter paper with sodium sulfate solution. Fix the paper strip with crocodile clips. Connect the clips to the terminals of a DC supply. Switch on the power supply. Using forceps, place a small crystal of potassium permanganate on the pencil line at the center of the filter paper. Observe the filter paper for 5 to 8 minutes. What color movement do you observe? Take a new strip of filter paper and mark with a pencil as before. Place it on another microscope slide. Moisten it with sodium sulfate solution. Add half a spatula measure of copper 2 sulfate crystals to a test tube. Add 2 cubic centimeters of aqueous ammonia. Stir with a glass rod to form a deep blue solution. Add 2 cubic centimeters of potassium chromate solution and stir again. Put on the crocodile clips. Add 2 drops of the deep blue solution to the center of the filter paper. Pass electricity for at least 15 minutes. Observe the color movement on the filter paper. What color movement do you observe?
So, dear students, you have seen the experiments that show movement of ions during electrolysis. In the video, you have seen how the purple color moves towards the purple color we say is due to the manganate 7 ions, and they are negatively charged, so they migrate to the anode, which is positively charged. In this video, copper chromate has been used, but in our lesson we described the use of copper 2 sulfate for the second experiment. And for the copper 2 sulfate, we said the copper 2 ions migrate to the cathode, which is negatively charged. And we made conclusions that anions migrate to the anode and cations migrate to the cathode during electrolysis. These ones are purple in color, the manganate 7 ions or permanganate ions, and the copper 2 ions are blue. That's why you see the colors moving to the respective anodes and cathodes during the process. All right. I also emphasized that on reaching the electrodes, we need to know what happens. On reaching the electrodes, what really happens there? The cations are discharged. The cations are discharged. Where are they discharged? At the cathode. To become atoms or molecules. The cations are discharged at the cathode to become atoms or molecules. How is this done? It's done by gain of electrons. So in the experiments we have just seen, we saw that from potassium permanganate, the cation there is the potassium ion. That's the cation. It migrates to the cathode. When it reaches the cathode, it forms potassium metal. And this is done by gain of electrons. So how do we know that it's by gain of electrons? This is the potassium ion and this is the potassium metal. The atoms are balancing in this half equation, or you say half equation. Because half equations are the equations you balance using electrons. Now, having a positive charge here implies that we have a positive charge of 1 on the reactant side, and there is no charge this side, so the charge there is 0. We need to balance the charges too. And to balance the charges, we must subtract 1 here to make this a 0. Subtracting a 1 to make this a 0 means addition of an electron. Remember, electrons are negatively charged. So subtracting 1 is the same as adding the electron which is negatively charged. Give us the potassium metal that way. I think that is very fine. Similarly, in the second experiment where we used copper 2 sulfate, the cation in that compound is the copper 2 ion. So the copper 2 ion, when discharged at the cathode, it will form copper metal. The atoms are balancing, but the charge is not. I have a positive 2 here and a 0 here. There is no charge on the product side. So to make this 0 means subtracting 2 plus 2 minus 2 will give us a 0. And how do we balance that? That means we shall add 2 electrons on the reactant side. So this implies that on reaching the electrodes, the cations are discharged to become atoms or molecules. So in case an atom is formed, like in this case, we have formed the atoms. The atom here is potassium, the atom here is copper. Electrons are gained. And gain of electrons is what we call reduction. It's what we call reduction. You can use a rig to help you remember that. Rig means reduction is gain. Reduction is gain. Gain of what? Electrons. Let us see many other happy equations for reactions that occur at the cathode. We have seen the first one, the potassium metal, the potassium ions giving us potassium metal. We have seen the second one, where copper 2 ions give us copper metal. Balance this by adding 2 electrons here. So that implies for reactions at the cathode, electrons are always added to the reactant side to show reduction. For the zinc ion from zinc metal, the equation is balanced by adding 2 electrons here. We call these half equations. For the sodium ion, we shall form sodium metal by adding an electron here. For the aluminium ion, we shall form aluminium metal by adding how many electrons here? 3. So the electrons are always equal to the charge here. Make your work easy. For the lead 2 ion, shall add 2 electrons to form lead metal. Okay, these are the common half equations. For the hydrogen ion, I've forgotten this one. For the hydrogen ion, we shall form hydrogen molecule or hydrogen gas. So here we need to balance atoms first by adding a 2 here. And then that makes the total charge here 2. So it calls for additional 2 electrons. The total charge here is positive 2. And the last one is silver. Give us silver metal. These are the common half equations you will come across during your interaction with electrolysis at the cathode. Now, we said that the anions, for the anions, for them, they are discharged at the anode. And for them, they usually form molecules. They rarely form atoms. They form molecules when discharged. And the discharge is by oxidation. So that implies at the anode, oxidation occurs. And oxidation is what we call loss of electrons. This implies that for all equations at the anode, electrons will be lost. Electrons will be on the product side. Let us see examples of common equations, half equations for reactions that occur at the anode. For example, if I have sodium chloride from it I'll have the chloride ion. It will give me chlorine gas at the anode. It will give me chlorine gas at the anode. Now this equation must be balanced by first of all putting a 2 here to balance the atoms, chlorine atoms. And when you look at this side, you have a charge of -2 now after balancing the atoms. This side the charge is 0. So how do you balance the charges now? You balance the charges by making this also to be -2. How do you make it -2? By subtracting a 2 here. 0 minus 2 will give you -2. And subtracting a 2 here means addition of 2 electrons on the product side. And this summarizes what I've already told you, that for the anode, equations there show electrons on the product side. The same will happen for bromide ions. Give you bromine. The difference is that for bromine, for it it's a liquid, and then 2 electrons. Oh, that's very clear. Then for iodide ions, we shall have iodine, aqueous, and 2 electrons. Molecules are formed in this case. Okay. For the oxide ion, we shall have oxygen being formed, oxygen gas. So we must first of all balance the atoms. There are 2 oxygen atoms here. This is 1, put a 2 there. The charge here is -4. So that means we shall add 2 electrons inside to have a charge of -4. And the last equation that usually shows a reaction at the anode is that one where the hydroxide ion is the anion discharged there. The hydroxide ion usually gives us oxygen gas and water. Those are the 2 products it gives us. So how do you balance this equation? Simplify your work. Simplify your work, count the oxygen atoms and balance them. You have 1 oxygen atom here, yet these are 3. So the best way is to avoid an odd number of oxygen atoms, wherever they are. If you want to avoid this odd number, which is 1, you will put a 2 here first of all. But when you put a 2, already you have 3 here. You have 3 on the product side, so a 2 will not work. Use a higher even number, which is a 4. When you use a higher even number, which is a 4, that makes them 4 oxygen atoms, 4 hydrogens. Of course, to call the 2 here, make these 4 hydrogens, 4 hydrogens. Then the oxygens are 4, they are also 4 here. That means the atoms are balanced. But how about the charge? The charge is -4. 4 times that -1. And this side you have a charge of 0, it's 0, it's 0. There is no charge on these. So how do you make the charge balanced? Make sure this 0 plus 0 minus 4 will give you -4, which is this side. And -4 means adding 4 electrons here. So in summary, these are some of the equations that you have to come across at the anode and cathode. First of all, these are reactions at the cathode, and then these are reactions at the anode. I once again remind you that you need this oil ring, which means oxidation is loss of electrons and reduction is gain of electrons. So I want us to make some mnemonics to help us recall the 3 concepts that occur during electrolysis. The first one is that oil rig, which means oxidation is loss and then reduction is gain. The other mnemonics is what? The other mnemonics I want us to understand. We have another one here that says ready cut. And ox. Ready cut and anox. Ready cut means reduction occurs at the cathode, and at the anode is where we have oxidation. That's so interesting as well. I think it is. So you can remember those ones. Oxidation is loss of electrons, reduction is gain. Reduction occurs at the cathode, ready cut, and at the anode we have oxidation. Okay. Maybe you can also think of Liora says Giroa. Liora says Giroa. Loss of electrons is oxidation. Loss of electrons is oxidation. And the substance that loses electrons is a reducing agent. Loss of electrons is oxidation, in brackets, reducing agent loses electrons. Gain of electrons is reduction, in brackets, oxidizing agent. That's what O&A stands for. So any substance that gains electrons is an oxidizing agent. Okay. And any substance that loses electrons is a reducing agent. I hope I've had a wonderful engagement with you. Please subscribe to our channel for more of these lessons. Let's meet in our next lesson, looking at what I will call preferential discharge of ions. Preferential discharge. Preferential discharge of ions. Thank you so much. Please like, share, and subscribe to our channel. I remain Joseph Jobs Kaida. You can get me on 0753 2470 98. Bye-bye.